Hey, I'm Belmont, and I am going to introduce every type of star in our universe to you, so get ready to learn. We think we know what a star is. It's a ball of fire in the sky. It's what our sun is. But our sun is just the opening act. Most of the stars you see in the sky are vastly bigger, smaller, or dead. Today we are going to look at every single type of star that has ever existed. First, we have to talk about the ones that almost made it. These are brown dwarfs. They have more mass than a planet, but not enough to start nuclear fusion. They are essentially failed stars, trapped in a state of warm failure. They never get bright enough to see without an infrared telescope. Because they never truly ignite, they spend billions of years slowly fading into dark, cold spheres of gas. Next is the real star of the show, a red dwarf. They are small, only about 10% the size of the sun, but they are incredibly efficient. While our sun will burn out in 10 billion years, a red dwarf burns through its fuel so slowly it will shine for 1 trillion years. Wow. Nearly 75% of all stars in the Milky Way are red dwarfs. If humanity survives, we will likely end up living near one of these. Their low energy output means any habitable planets would have to orbit so close that they would likely be tidally locked, with one side in eternal day and the other in permanent night. This brings us to the sun, a main sequence star. It's in its stable adult life, perfectly balancing gravity with the outward pressure of fusion. But it won't stay this way. When it runs out of hydrogen, it will swell into a red giant, consuming Mercury and Venus. As a red giant, its outer atmosphere will become so thin and expanded that it could reach all the way to Earth's orbit. Then, it will collapse into a dense white dwarf, a cosmic diamond the size of Earth, glowing only with leftover heat. This remnant is so incredibly dense that a single tablespoon of its matter would weigh as much as an elephant. Now we move to the giants. A blue supergiant is massive and extremely hot. Because they are so massive, they burn through their fuel in just a few million years. Their intense surface temperatures, often exceeding 30,000 degrees, cause them to glow with a brilliant, lethal ultraviolet light. When they reach the element iron, the core collapses instantly. The resulting explosion, a supernova, briefly outshines entire galaxies. These explosions create the very elements in your body, like the iron in your blood. In those few seconds of collapse, the star produces more energy than our sun will emit in its entire 10 billion year lifetime. If the core survives the explosion, it becomes a neutron star. These are so dense that a single teaspoon of this star would weigh 1 billion tons. They possess magnetic fields quadrillions of times stronger than Earth's, enough to dissolve the atoms of anything that gets too close. Some of these spin hundreds of times per second, emitting beams of radiation like a cosmic lighthouse. We call these pulsars. But if the star was big enough, the core collapse doesn't stop. It collapses into a point of zero size and infinite density. A black hole. A place where gravity is so strong, even light can't escape. Once anything crosses the invisible border known as the event horizon, it is lost to the known universe forever. It is the final resting place of the most powerful stars. From the smallest failed dwarf to the singularity, every star has a life and a limit. Scale is everything. Oh, I forgot to mention one more star that doesn't seem to stop shining since its birth. It only gets bigger and brighter. And that's you. This is for your brains. Stay informed.